Welcome to clickmyproject.com. Video denoising using NSVT algorithm. Video denoising is a technique to decrease the noise level at the video frames using the NSVT transformation. In this process, we take the multiple frames to convert each single frame and to add the noise at the converted video. Add the noise to remove as the median, filter the frames and to reduce the multiplicative noise from the videos. They filter the frames and reduce and multiplicative noise to exploit the less strengthened design condition of the NSVT to design the filters that lead to NSVT with a better frequency selectivity and regularity when compared to the controlled transform. We propose the design framework based on the mapping approach that allows for the fast implementation based lifting and ladder structure and only uses one-dimensional filtering in some cases. In addition, our design ensures that the corresponding frames elements are regular symmetric and the frames is close to a tight one. We access the performance of the NSVT image denoising and enhancement applications. The set of basis functions completely characterizes the transform, and this set can be redundant or not, depending on whether the basis functions are linear dependent. By allowing redundancy, it is possible to enrich the set of basis functions so that the representation is more efficient in capturing some signal behavior. This is the flow of the process to video denoising using NSVT algorithm. In this paper, we have two proposing method is of video denoising. The already existing is used in the image denoising, and for a feature enhancement we have to use the video denoising of this process. In the first process, we have to take one input image and apply to the pre-processing techniques. In that, the pre-process is one of the process which helps to prepare the image proposed to work. In pre-process, input trace to be pre-processed the grayscale and adding a noise and removing the noise to be improve the quality of input image. Then the feature values is extracted from the input phase is extracted corresponding features of phase of the input image. The next step is to be the converted the video to the frames conversion for easy to use in the NSVT algorithm transformation. The NSVT algorithm is very effective for the noise adding removing purposes on the video. In this model, we have to add the noise to the input video to transform the image to the NSVT form. Using different noise techniques to be added to the input frames such as the salt and pepper and speckle noise also. Use certain levels noise to be added the noise video easily for further steps for the project. Then the NSVT transform is powerful transform. In this model, we have to use the basic domain to domain transform. The method to transform the value one to another named as NSVT. In this model, that smoothing the boundaries of input frames using coefficients denoising either denoised images that decompose the frames to build the coefficient of this model. This control is mainly used for the double filter bank structure to get the input images, obtaining the levels of coefficients of the input phase of another process of the input image. Then the classification. The classification is powerful technique to retrieve the video from after the denoising is very to be effective usefully. The classification is used to classify the feature and identify the frames to check whether obtain the noise or not. In our pre-process, we have to obtain the output image from improve the quality of images to filter the frames. This steps using extract the features from the given images and then perform the classify to all images each by each in the database. This technique is very useful to select the right frames from the existing dataset the video. Then we have to conclude our process. The final model in denoising the video from the removing the noise from the frames. Efficient type of filters to be used in the process removing the noise. Finally, calculate the performance values of measure the PSNR value of the denoised video. Here converted the video frames again convert to the output frames. Now we have to conclude our process. The conclusion is very effective from the image denoising to the video denoising. In this process, we take the original input video and then converted the frames, then add the noise to the video form to change the frames easily, to apply the NSCT to the input frames. Finally, apply some filtering techniques to converted frames from to the denoised input frames and then converted again video. Thank you. This is the MATLAB window, main window of our process. Whenever you run any coding in that line, pick the file from the current folder. This is a command window. Whenever you run any coding in our MATLAB, executing part is viewed in that command window. This is the workspace. The workspace is viewed as a variable under functions and values used in our coding. This is the command history. The command history is nothing but you using any variables and values in that command window is to be viewed in the command history. In that current folder, select the test main file, then click the sound over ma'am. Hello. You select test main.m, right click the test main, click run. Now we have to window for choosing the input video for our process. I select the medical window or business window. I select video. I select the medical video for our input. Click open. The frame conversion is obtained after the input videos to be played and then the noise added to the input video. The noise adding is improved in that salt and pepper noise that improved the size of the pepper noise. Now we show the output is the NSCT. The NSCT is to be for both for 4 coefficients level. The first level of that in that, and the next level is to be performed in 4 level. The 4 levels to be the noise related and the edge related windows to be performed. The final process is the denoised video. The denoised video is to be denoised from the salt and pepper noise. If you need to powerful video, you modify the levels of adding noise in the process. The both noise and unnoise for transformation windows to be viewed in this process. This is the bar chart. In this chart, we have to define the frames and PSNR values from the label fixed in the PSNR value. The performance evaluation is viewed for total number of frames the video. Now we have to conclude our process. In this process, we can take the original input video and convert it to frames and then add the noise that video form to change those frames easy, to apply the NSCT to the input frames. Finally, apply some filtering techniques to convert frames from to denoise the input frames and then convert it into video. The current approaches on the basis of NMS usually need 2 iterations on conversion when compared to the proposed method, but the same or better results can be attained by our technique, less iterations. Then performance is to be compared with other mentioned techniques both from the visual and statistical standpoints. Thank you.